This is question 14 from the GATE 2018 EC paper, where we are given that x of t is a periodic function with period t equal to 10, and it has the following Fourier series coefficients and representation with the coefficients denoted by ak. And we are asked to find out if we were to consider that the period was 40 and obtain the Fourier series coefficients as bk, right? What would summation k equal to minus infinity to plus infinity absolute value of bk be if the same thing for ak is 16? Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. So let us look at solving this problem. Over here, I have given the Fourier series coefficients ak with the formula and the representation of the function x of t in Fourier series representation with the coefficients as ak, right? And just so that I have a different index for bn for the coefficients b, I have used the index as b sub n, right? So b sub n, you can see, has a period of 4t, where t is the period for the coefficients corresponding to a, right? Because it was t and 40, so that's 4 into t. T dash is 4 into t. So over here, let us see what happens when you substitute for x of t this formula. So when you substitute that formula, you will get it as so, right? And you can of course multiply these two exponentials and you will get this expression for b sub n. You can interchange the summation and integral so as to have only the exponential inside the integral, right? So you can clearly see that the only thing sort of relevant with respect to the index is k minus n by 4. Now there are only two possibilities because k minus n by 4 ranges over all integers. There are only two possibilities for k minus because k ranges over all integers. K minus n by 4 can only have two possibilities. That is, it's not equal to 0 or it's equal to 0, depending on the value of n, right? So what we get, let us look at both the possibilities. So when k minus 4 n by 4 is not equal to 0 and k minus n by 4 is equal to 0. So for k minus n by 4 not equal to 0, you will be, now this is a significant exponential. That is, the exponential has a significant power to it. So therefore you can use the integral of exponential formula and then substitute in both the limits, right? And do the subtraction and you will find that this is equal to 0. And of course, when k minus n by 4 is equal to 0, then this whole this is like e power 0, which is just 1. So yeah, I'm just substituting 1 over there and it's equal to 40. So going back to where this all came from, it was for this expression for b of b sub n. We had two possibilities for k minus n by 4, and we saw that for whenever k minus n by 4 is equal to 0, we found that this exponential became 0, and when it whenever k minus n by 4 is not equal to 0, this expression became 0, and this expression became equal to 4t when k minus n by 4 was 0, right? And so therefore, what will we get for b sub n now? We'll basically get b sub n. So the only term that will so the idea is that in the case of n is equal to 4z, right? In the case that n is equal to 4z for some integers, for some z is integer, we'll get that for k is equal to z, k minus n by 4 is z minus z 4z by 4, right? I've taken n is equal to 4z and k is equal to z. So that is z minus 4z by 4, which is equal to z minus z, which is equal to 0. So k minus n by 4 is equal to 0, right? So it is only going to be in the case that n is equal to 4z, where n is the index of b sub n, that the summation term is going to be that the so in this case, only the k equal to z term will come out of the summation. You can say that only when k equal to z, right, this k minus n by 4 will be equal to 0, and so that will only come out of the summation. Which summation? This one, right? So now what you will get is that this is equal to, so remember only the k equal to z term will come out, and k is the coefficient of ak. So that is 1 by 40 comes here, and that is az times, what is the value of the integral? It's 40. So 40 40 will cancel, and what you will get is that b 4z, remember n is equal to 4z, so b 4z is equal to az. And as you know, in the case where n is equal to 4z plus r, right, where r is either 1, that is 4z plus 1, 4z plus 2, 4z plus 3, any of these cases, we'll get that no terms come out of this summation. The summation is just equal to 0, right? So what we will get is for Bn, that is what we'll get for the coefficients of Bn are Bn is equal to a sub a n by 4, a n by 4 for n is equal to 4z, and 0 otherwise, right? So this summation n equal to minus infinity to infinity, absolute value of Bn, can just be given as the summation where n is equal to 4z, z belongs to integers, a n by 4, which is just summation z belongs to z az, which is what we already have in the problem statement as being given as 16. Thus the correct option is C. C 16 is the correct answer.